All right, good. I guess it's good. Good evening, everyone. Uh, Kindly asking if one of you could just confirm if you can hear me just fine. Thank you very much. Uh, whew, um, yeah, so I'm not really sure. I think I'm losing track of conversations here, the series of classes I have. So I'm not really sure if I'd mentioned that I was going to be attending this year's ICTA's event. I don't know how many of you are actually in Livingston attending the same event. Maybe, maybe not. Um, if you are, then you probably saw me or something yesterday because together with Professor Kaleji, we we were facilitating some an AI training session. It was a day-long AI training session. It was quite interesting, really. Um, there are people from all over here. Copperbelt, places like Mopani, First Quantum, NAPSA. There's a whole troop of people from NAPSA. Places like ZRA as well, always represented like that. And I'm glad to say that I have had some very fruitful conversations with some interesting people, especially as it relates to some of the things that we're discussing right now. Interesting stuff. I literally today, right after the president's address, I was chatting to Mr. Mbewe, who works for NAPSA, and they have a whole range of problems, right, that he's convinced they can address by leveraging endless potential, if I can add, of AI, right, and perhaps machine learning or something. So quite a number of interesting things here. Out of interest, is there anybody who is attending the event? I'd be surprised if nobody. Thumbs up if you're attending the ICTA's conference expo speedy training / AGM. They've packed everything all in one or something. Very strange, right? I find it odd that none of you are attending this session when I think you get CPD points or something like that, continuous professional development. And usually, for most organizations, right, motivating for you traveling to attend this event is not that difficult. Like, I think there are about 5 people from UNZA CICT who are attending the event. Yeah, bumped into people from Zanaco and all of this. Today was especially interesting here, I guess because of the keynote that was given by the president, His Excellency, Hakainde Hichilema. But anyway, so quite a number of. I was hoping I would be able to showcase the program here, just in case you are not aware. Maybe I can actually. So it's been quite interesting. Yesterday, my part was just restricted to how you'd go about setting up a local LLM or something like that. We see it as like low-hanging fruit. Normally, when we have this sort of sessions, I almost always volunteer, to I don't know why this thing is not showing anything here. I almost always volunteer. There we go. I almost always volunteer to facilitate the section that speaks to local LLM. So yesterday, I was using Parliament and ZRA as an example. I was telling them that you can actually create a local LLM. Like, so we created a ZRA assistant, by doing some very, very mild and crude customization to the Llama 3.2 model, right? I don't know how many of you have played around with local LLMs here. The interesting thing is always trying to tell people that there's there's a whole bunch of reasons for why you may want to set up a local LLM, right? For one, I mean, I don't think there's an organization out there that can claim that none of our employees use LLMs. Everybody is using these chatbots, right? At work, actually, ChatGPT doesn't matter whether you work for the central bank. We have people here who work for the central bank. There's a person, maybe two people that are coming from parliament or something. Your colleagues are using these LLMs. In fact, you are using these LLMs, right? So that poses security risk and all those things. And so you may wish to set up your own local LLM. So we're doing this, right? It was quite interesting here. I may not stick around until Friday here, but you notice that there's a whole bunch of interesting things happening. So we were, Professor Kaleja and myself were facilitating this session here. It was a parallel session which was running in parallel with the cloud computing and DevOps kind of session here. Anyhow, yeah, some really interesting things here, and everything is tied to the theme here, Zambia 60 billion economy by 2031 here. But anyway, so we're going to continue our discussion, colleagues, I guess, I don't know. We're going to continue our discussion of CSC 5741, and I wanted to remind us that we have gotten to a stage where we've discussed at length so-called data mining models, right? So approaches to systematically executing the various operations or activities associated with your typical data mining pipeline. Okay, we focused our attention on the so-called CRISP-DM methodology. However, we also had a lengthy discussion of SEMA and KDD, so knowledge discovery databases, right? And all the while we're essentially trying to compare the different phases in these different approaches. And what we begin to notice is that there are striking similarities. The phrases or the names of the stages may be different, but really the activities that you perform are the same. In some instances, we discovered something really interesting: the fact that there are stages or phases that would be missing in some of these approaches. Like for instance, you do not have business understanding in SEMA, right, or KDD ideally. So we had a discussion of these things here, which was quite interesting here. So today, what I thought we'd do here is I thought we'd go through a series of use cases. I have 3 of them, but perhaps I'll throw in some things that came out of my interaction with a lot of interesting people during my stay in Livingstone. So towards the end, I'll talk about, there's some colleagues from Opani. I was talking to Mr. Livati yesterday, who had attended another session, a training session we had conducted towards the end of last year. And he was talking about how they're planning to fly around with drones and try and see if they can automatically detect anomalies, right, or problems or issues with their infrastructure, right, so in the mining sector. The classic computer vision kind of problem here. But anyways, so again, the goal with the remainder of this lecture series, today's session at least, or perhaps the first part of the session, is we want to put to practice the CRISP-DM methodology. We want to see exactly how the CRISP-DM methodology would actually manifest itself given a real-world problem. I'll encourage you to ask questions if you have questions, or perhaps at this stage of our careers, I guess, if you have something meaningful to say, please. We should be having very, very high-level discussions, right, at this stage of when we're pursuing these advanced degrees ideally. So I want to start off with this problem. This case one is a project that we embarked upon to automatically generate ETD metadata, right? I think is this the one? Let me see here. Don't know. Is this the one? Yeah, I guess it's the one or something. Okay. So remember that everything starts with a problem, is it? Like I'll give you an example of the problem that somebody from NAPSA would like for us to chat at length about. He wants to co-opt me into what they're doing. Is to do with fraud, right? So the problem they have is that people have taken advantage of things like these partial withdrawals, and they're stealing money, right? So the thinking is, they can leverage computer vision here to try and identify, those kind of like fraudulent transactions, if you will. But anyway, so in this particular case, the problem is simple. I'm going to set the context here so that you appreciate the steps that we followed for us to execute this project, right? So the University of Zambia the University of Zambia is a teaching and research university. It's a public teaching and research university, the largest and oldest in the country, and we're very proud of that. And it turns out that if you're a teaching and research university like the UNZA, the expectation is that besides one of the core mandates that people would expect you to do, which is teaching, you're expected to do a whole bunch of other things. Okay, so University of Zambia is supposed to play an active role in terms of contributing to the community, right, through a series of community engagement activities. The expectation also is that people that are employed by the UNZA are supposed to conduct what's called consultancy, right? So they're bringing money to the university. And then more importantly, the UNZA is supposed to conduct research, and this is really an important aspect of a higher education institution, a teaching and research higher education institution. Now, when it comes to research, it turns out that there's a lot that goes on there, but the final product of any research project is a publication. Okay? So a publication can be a conference proceeding paper, it can be a journal article, it can be a report, it can be a policy brief, it can be a whole bunch of things. It could be a presentation. Okay? So what the UNZA has done is it has set up infrastructure. Yeah? Infrastructure that is meant to make available research output, right? That key output associated with research. So for instance, there's a journal platform, right, called the University of Zambia Journals platform. So you can get access to the University of Zambia journals platform by going to journals.unza.zm. You find currently a total of 15 journals, right, affiliated with the UNZA. It's a lot, considering the fact that a number of these other universities will probably have maybe one multidisciplinary journal or something. But because we are so large and we do all sorts of things here, life sciences, physical sciences, social sciences, education, and all those things, law, it makes sense that we have like a number of journals, right? However, a journal article is not the only output, right, associated with research. Like I said, it could be a conference proceeding paper, it could be a technical report, as is the case in our fields, right, computer science or computing, or it could be a book or a book chapter. So what the UNZA has done is, besides the online journal platform, the UNZA has what is called an institutional repository. So an institutional repository is a piece of software, an information system software, which is aimed at facilitating access to research output or scholarly research output, managing that scholarly research output, and preserving or storing it over a prolonged period of time. So three key things. And in essence, an IR, an institutional repository, is a type of information system that is typically referred to as a digital library management system, right? In essence, you're creating digital collections, ideally. Okay? So the UNZA uses this institutional repository to make available, ideally, all publications, scholarly output produced by people at UNZA. Okay? Academic members of staff at UNZA. So, for instance, I'm looking at an example here. I'm getting into the School of Education. Maybe it's not a very good thing here, but it's School of Education, all of the departments in the School of Education, and we're looking at the outputs, right, generated by this particular entity. Yeah. So what the UNZA does actually is that it has set up this platform so that It is used to make available or to store and also manage all the different types of Scala research outputs. So in here you will find things like conference proceeding papers, right, by members of staff. You'll find things like journal articles. There could be preprints, and we're not discussing the gory details of licensing agreements that may be there, that would tend to dictate whether or not you can actually make available things that have been published elsewhere here, right? But everything is made available here. Now, a crucial aspect of research for any type of higher education institution out there, UNZA included, is the output that is typically produced by people that are pursuing these advanced degrees, right? Postgraduate students. And in fact, if you speak to the average person out there who understands what research is all about, they will tell you that a significant proportion of research is actually produced by people like you, right? So PhD students and master students. So I'll give you an example of Professor Piri, for instance. If you go to Professor Piri's profile, very accomplished scholar, right? If you look at his H index, it's 22. It means a lot here, right? What you begin to notice if you look at the publications done by Professor Piri is that in almost all of these instances, he is a co-author of these publications. So I can make an educated guess here to say most of these are his students, is it? Masters and PhD students, right? J. Piri. You notice that the students are first authors here, right? Whereas he's a second author, something like that. This may be different here, maybe collaborated with a colleague or something like that, right? But for the most part, what I'm trying to say here is that people such as yourselves, postgraduate students, are an integral part of the research process. In fact, the average person, researcher like myself, will tend to do quite a bit in terms of research because he works with or he supervises or advises students, postgraduate students. So you're offering strategic direction and guiding the student, and then at the end of it all, there's this output, maybe journal article, conference proceeding paper. Okay, so what I'm trying to say here is that students like yourselves are extremely important, right? Now, it turns out that for you to graduate, one crucial piece of research output that you are required to submit or to produce is what is called a thesis or dissertation manuscript, right? Manuscript. So this is a long document, right? Depending on what you are studying, it could be a discourse or it could be a tenet, right? A dissertation is a discourse. You're not really mandated to demonstrate that there's something extremely novel about what you're doing, right? It's different from a thesis. So it's a thesis or dissertation. A dissertation is typically associated with master's degrees, whereas a thesis is associated with either a master's by research or PhD, PhD program, right? Save for professional PhDs, right, which coursework on it, ideally. Now, if you look at the University of Zambia Institutional Repository, right, it's structured in such a way that content in there is organized into so-called they're container structures, right? At a very high level, you have a community, right? After a community, you can have optionally a sub-community if you wish, or you can have a collection. Underneath a collection, you can optionally have a sub-collection, right? Or you can actually start adding things to this collection, right? So I'll call these bit streams, ideally. Okay, I'll call them objects. Okay, so one of the container structures in the repository itself is a thesis and dissertation collection, right? So if you go to dspace.unza.zm and you go under communities and collections, somewhere at the bottom you'll find a community called thesis and dissertations. If you access the thesis and dissertations community, ideally this community was created to archive theses and dissertations produced by masters and PhD students enrolled in postgraduate programs at the University of Zambia. So in fact, you notice here that there's the community thesis and dissertations, and then there are collections that mirror the different schools that we have or faculties. Is it? So in our case, we are from the School of Natural Sciences. It's probably going to be on page number 2 because it's N. You notice that we have School of Natural Sciences here. When you go in here, you will have access to all the theses and dissertations that have been submitted in the School of Natural Sciences. And if you look at the top here, where it's now showing 105 of 419 here, the School of Natural Sciences ideally has thesis and a total of 419 thesis and dissertations. So in other words, you expect that students that would have graduated from the School of Natural Sciences with a master's or a PhD are somewhere around 419. I'm saying somewhere around 419 is because the university has a backlog, so there's still things that have not yet been uploaded. Okay. Anyways, so it turns out that these things that you have in the repository here have got to be added, right? Like any information system, you do your CRUD, is it? You have your CRUD here. You can create, you can read, you can update, you can delete records or something. So when these records are being created, they are created by human beings, right? Typically from the library. So every time students are about to graduate, like this time around, there are a number of oral exams that are taking place. Incidentally, one of my students is doing his presentations next week on the 25th. I do encourage you to attend if you're interested in medical imaging, ideally. So at the beginning of the year, or somewhere around May, we have a lot of students that will graduate. It's a lot, right? Postgraduate students. Let's just say postgraduate students, right? Close to 100, if not more, this time around. I'll have to check my stats here, but it's a lot. Now, it turns out that the process at the UNZA is such that before you can graduate, you're supposed to submit the corrected version of the manuscript. They'll tell you need to print. If you read the guidelines, they'll say you need to print the manuscript, and you print and you bind it nicely, 4 copies, and then also you burn, right, a copy of the manuscript on CD or on a DVD, right? And then you submit that to, I don't know if it's because of decentralization, to the school. What the schools will do then, the assistant dean postgraduate will do, is they will send, right, the CD to, usually it was DRD, I don't know if they still send it to DRD, and then DRD will send those CDs and a copy of the dissertation, so that it's there in the library, to the library, okay? And it turns out that in the library, there are people whose job is to get what's on the CD and upload it to the repository. Now, it turns out that the process of uploading content to the repository is not as trivial as you may expect, right? Because the things on the repository are organized in such a way that they'll have they're added there. The things that are added there, it's an object itself, right? The thing on the CD is an object, huh? But it turns out that this object comprises of 2 main components. There's a bit stream, right? This would be the PDF document, and then there is metadata, right? It's descriptive information. I'll just say it's text here. So it's auxiliary information about the PDF document itself. And this information is important because it facilitates, discoverability of content, is it, searching and browsing. Because you have a lot of things in the repository, you want people to be able to easily find whatever it is they're looking for through searching and browsing. Okay? So this example dissertation, you'll notice, is associated with a bit stream, right? This document that I can download. I guess I can download it right now. Okay? And it's also associated with descriptive information. So descriptive information includes things like the title, details of the contributor, the author in this particular case, the student, the dates when this document was published, when it was uploaded onto the system, right? The type of object. Is it a thesis, a dissertation, is it a conference paper? The abstract, right? That succinct summary of what the manuscript is all about, because it's a long document, obviously. Right? Unique URL, which is automatically generated. The language associated with this thesis and dissertation. The publisher, almost always the University of Zambia, except in instances where somebody is doing a sandwich program with a different university. Type. And then you have other things here, right? Still auxiliary information, like the name of the file, right? This was named the main document, which is really horrible here. The format, the size, right? Details of the license and all those things. Now, it turns out that this auxiliary information, in some instances even the subject, this auxiliary information has got to be prepared by an expert. So librarians are trained to do these things. Right? There'll be, when somebody reads this, it will tell you we need to associate it with these sort of subjects. This is computing, hardware, software, and all those things. This is information that is not provided by the student when they burn this thing to CD. What else? Things like the publisher, the student won't specify these things, right? So it's the people from the library that will do these things. So it turns out that this process is it's manual, it's error prone, right? And it's tedious, takes a lot of time. So the problem that is there, the other problem that is there is because this is manual process, what the UNZA does is, and in part because there's really no policy direction, what the UNZA has done is they prioritize what sort of elements to include here. As a result, over the years, the things that they're adding into the repository are missing crucial information. There's a lot of important information that is missing. Some information is just riddled with errors and all of those things, right? I'll give you an example. I'll use a gold standard repository, my alma mater. I love my alma mater. If you look at the institutional repository for the University of Cape Town, this is it, right? And if you look at the sample manuscript, I'll use my doctoral thesis as an example. You will notice that the metadata that is associated with theses and dissertations at the University of Cape Town is comprehensive compared to the UNZA repository. Right? I want to draw your attention to, there are a lot of things that you can literally see as I'm scrolling here that this is more comprehensive, but you will notice that the University of Cape Town specifies who was the supervisor or advisor. Okay? It turns out that this is important information when, you know, certain individuals are looking for content. Like for instance, maybe you, when you come back, imagine you're coming to the UNZA for the first time to come and do your PhD. Maybe one of the things you may want to do is, I want to see all thesis and dissertation manuscripts that were supervised by Professor Piri, Professor Jackson Piri. You know, it turns out that it's difficult right now if you go to the UNZA repository to do that. There is a whole slew of other problems associated with institutional repositories, but I want to focus on this important metadata element called the advisor or the supervisor. And it's important for us because for the longest of time we are working towards setting up a national ETD portal, right, which will be pulling ETDs from all the universities in Zambia, ideally. And there's a lot of universities here. UNILAS, Cavendish University, the University of Zambia, Kapasa Makasa University, Copperbelt University, Chalimbana University, Zcast University, right? The whole 9 yard here. Palavana University. But anyways, so this is missing, right? So if you go to this document here, it's like, who supervises this work? We don't know. It's not there. There's nothing here in the metadata. Who supervises? We don't know, right? We don't know. So it's a problem we're solving here. The fact that completeness of metadata is problematic for the UNZA repository. Okay? if you really look at the metadata elements in the UNZA repository and compare them with international standards like the ETDMS metadata scheme, you begin to notice that we're doing so many things wrong, right? Now, like I said, the metadata element we are focusing on here is the supervisor advisor, right? There are a number of things that are missing here, like departments are not there. So if you look at this dissertation, you might be interested in which department exactly is this. I know it's School of Natural Sciences right here. It's here, right? Natural Sciences here. But which department is this? Because Natural Sciences has a number of departments: pure and applied mathematics, computing and informatics, pure and applied chemistry, right? So where is this coming from? It's geography, right? There's biology, right? Where is this coming from? We don't know. It's not there, this information. So anyway, so the problem we are attempting to address here is how do we fix this? Because here's the thing. You have a lot of things, right, in the repository right now, a lot of ETDs here. If I go to, I don't know if I can go to ETDs, thesis and dissertations, I will just go to by issue date. The UNZA repository currently has 5,725 dissertations. The easiest solution to solve this problem is you say, we are going to go back into the system and we're going to update the system, is it? So for all of these 5,725, we will start updating them by adding the supervisor details. But that's not practical, is it? We already have a backlog as it is. The UNZA library is behind. So updating is obviously not practical. It has financial implications. You'll probably have to hire interns, and that would be error prone. So what we're saying we can build a solution, right? And the solution we envision, a potential solution here, would take advantage of a subfield of AI called natural language processing, right? In particular, we can say we can take advantage of named entity recognition, or NER. So this notion that given a chunk of text, you can identify names of things, names as they relate to people, buildings, organizations, and all those things, right? Entities, named entity recognition. So the first starting point is like, we need to identify exactly what sort of data we're going to use, right? Because it's a data mining problem, or the solution we've carved out is data mining centric. So if it's data mining centric, it's like, where is the data going to come from, right? Where are we going to find the names of these supervisors? Okay. So once we carve out that solution here, the question is, I mean, how would we look through those phases of the CRISP-DM methodology? We obviously start off with business understanding, is it? Yeah. If you remember, we had a series of operations that we do, right? We come up with general and specific objectives, do a situation analysis, and all those things. So in our case, for this particular problem, right, we outlined, business and data mining goals here and objectives, right? So the goal here was to devise techniques that would enable us to utilize ETDMS standards and be able to kind of like generate, right, details of these advisors for each thesis and dissertation. Okay, simply put, like a data mining goal here is to automatically generate contributor details. So in this particular case, we don't know who supervised this person, but wait, this person, thesis and dissertation. So we want to automatically generate that metadata, right? And figure out a way of just injecting that metadata into the repository. I mean, injecting it into the repository is not difficult. You can automate this, right? We have done this in the past, actually. So there's nothing complex about it. Okay. We conducted a situation analysis, right? And the goal of the situation analysis, we wanted to figure out exactly how this would be done, right? Using current workflow. And it turns out that we conducted this situation analysis by performing a content analysis of ETD manuscripts. So it's like we want to automatically generate details of supervisors. The first question we asked ourselves is, where do we find the details of the supervisors? And we realized, right, during our situation analysis, that the postgraduate guidelines would probably have details outlining how these thesis and dissertations are supposed to be structured, formatted. Right, so a content analysis didn't just look at ED manuscripts, but also looked at the important policy documents. In this particular case, the postgraduate guidelines. But what was especially crucial is we did a content analysis of ETD manuscripts, right? So we literally sampled, right, documents like this. This is 103 pages. And a content analysis, in essence, in this particular case, is we're trawling through these documents, right, like this one. We go through it to try and figure out where can we find details of the supervisor. Where is it, right? And I'll let you in on a thing here. It turns out that during our content analysis, we discovered that almost all students, right? In fact, it's world over, not just UNZA, will typically include details of their supervisors in the acknowledgement section. So here, if you notice, gratitude goes to the University of Zambia for making this research a success, yada, yada, yada. I equally express my gratitude to my supervisors, Dr. K.H. Mwanga and Dr. G. Membele. Okay, so already here, our content, our situation analysis kind of like gave us an idea of where this information will be coming from here. Okay. What else do we do under business understanding? Well, we have got to come up with a project plan, and this is simple, really, right? In our case, it's like we are using these 6 phases as our summary tasks, and then we decompose. We identify the subtasks associated with those summary tasks. We identify the milestones, the deliverables, yeah, and then we use that to come up with work breakdown structure. Using the work breakdown structure as input, we derive a Gantt chart, and then we have our timeline. Okay, simple stuff here. And then of course you kind of like come up with is it a resource breakdown structure? You look at risks, the whole 9 yards that you do as part of project planning. I don't know if this is making sense in terms of data business understanding. Okay.
Yes.
Yeah, it's a lot. Right. So we do this, and the next stage, right? If you remember our discussion of this, is the next stage is we go to data understanding. And for data understanding, if you remember, we said one of the things that you've got to do is you have got to identify your sources of data, for instance. You do some preliminary data collection and all those things. I don't know if you remember that here. Okay. So in the case of identification of data sources, we realized here that after our situation analysis, we realized that our source of data was going to be the PDF documents submitted by students, right? The bitstream, in essence. This. Now, the bitstream itself is a long document, is it? You have like hundreds of pages. If it's a doctoral thesis, for instance, it could be even more than 200 pages. What we discovered, though, is that there's this particular section in the document, specifically in the preliminary pages, right? And so we identified the acknowledgement section as comprising the things that we are looking for, supervisor details. In terms of the initial collection of data, the question we're attempting to answer here is, well, we know that we will need to analyze the PDF documents, but and a particular section in the PDF documents, but how do we gain access to the PDF documents? Now imagine you're collecting all of these 5,000 725 documents. Yeah. How do you get a hold of them? Well, we did our due diligence, right? As part of data understanding, we realized that the platform used by this institutional repository at the University of Zambia has an API. Okay? It has an API. So, specifically speaking, the API itself, the default is such that what you're harvesting metadata elements that are encoded using Dublin Core, right? So this API here, if I get the URL, by the way, maybe this will make sense. Don't know. If you look at this prefix here, OIDC, right? It's different ways of formatting data from this API. If you look at metadata formats, one of the metadata formats here is ORE, right? Object Reuse Exchange is called. It's a whole. You just look at if you look up OAI ORE, you have a whole specification that you can read if you are interested in this space. I've had too much of this. I've read it over and over again. But anyway, so there's that, right? So ORE. So what we do, we realize that when you're playing around with these endpoints, what you can do is you can flip these metadata prefix here and just change this to ORE. Is it ORE or just ORE? So that when you come here and you type and you paste or you access this data using the ORE metadata prefix, you will have access to metadata that is formatted like this. Now notice there's a difference, right? This, but why now? DC has, this is the same record, by the way. You notice DC creator, DC subject, DC description, DC date, DC language, blah, blah, blah. But the ORE, look at this, right? The schema is completely different. But what we're interested in our case is somewhere in this is a direct URL, right? That will give you a direct link to the PDF, the bitstream itself. And specifically, it's this, right? It's this. If you notice, title here is .pdf. So it's this link. This link here, using ORE, this link, but come on. This link here, this thing here, is a direct link to a PDF document. If I copy this and paste it here, in fact, I don't have to paste it. I can paste it though. It will give me access to a PDF document, right? If I get that and I do a wget or something like that, I'll likely get 741. Ooh, playground. If I get that and I do a wget here, I will download that document. Boom. I don't know why it's then forbidden here. Very weird. I don't know why. I will have to look at it a bit more. I don't know why wget is failing here. I don't know why it's failing. But anyways, I can look at this later on. The key thing here is that the OAI ORE is the one that was giving us access to a direct link to a PDF document. Oh, what we could have done here is we could have said, well, we're just going to use the same this same thing here, and then just use the direct link, which is this, that takes you to the metadata page like this. That's another option. We'll get this link, and then when we get to the landing page of that, the metadata itself, we will scrape, right? We'll scrape for this link here. And I guess this link would be, but why now? We will scrape for the link itself. This link would be, and check here. You'll be able to get the link, which is here actually. You notice here, this, right? So we can scrape as well. So a couple of different options, but the key thing here is we were able to identify, right, how to extract, and we did some initial data collection here, ideally, What else? It turns out that crucial to building models and all those things is, especially if you're leveraging supervised machine learning or as part of evaluation, is labeling, right? So we needed a way of creating a labeled dataset, and I'll explain more about labeled dataset towards the end here. Our labeled dataset was important because when we build a model that tells you to say, well, we're able to automatically generate the supervisor details as being Professor Jackson Peer for this student. It's like, to what extent can we trust that the model has done the right thing? You've got to conduct some evaluation. So how do you evaluate? You evaluate with what the model has done with the gold standard. So the question here is, how do you build the gold standard? Well, we built a labeled dataset. And that was another process itself. We built that labeled dataset by harvesting information using this protocol, the OAI-DC protocol, and then we kind of like organize this information in such a way that human beings were recruited to label this dataset. So I recruited students. I did this myself. I recruited students. They were in second year, I think. I don't know if it's second year or third year at the time. It was a while back, 2019, I think second year, during one of the long vacation periods. And I paid them money, right? Project money. And so they were labeling this data. In fact, I don't know if I have details. There we go. Somewhere at the back here. Somewhere at the back here. Here is the labeled dataset. And I'll open it up so that you can see it later on. Maybe I can do it right now, I don't know. So we harvested the metadata, and I think I can do this. I must show you this so that this sinks in. All of this, by the way, is part of like the process itself, right? You notice that I'm going through the CRISP-DM methodology or something. I think it should be under this, and then I don't know if it was 2019 or labeling this project here. Can't even remember why it was called Project Q here, but so they were recruited, and they were trained, they were oriented on what was expected of them. So I walked them through the process of labeling. I prepared a nice guide, which is what I'm about to open right now. I don't know if it's going to open here, but maybe I should download it. There we go. I prepared a nice guide like this, right? Telling them quick guide to transcribing ETDMS metadata fields, right? Came up with something like this here. Yeah, something like this. So it was a while back here. Somewhere in 2019, you notice this was uploaded in January 2020 or something like that. And then what these students were doing when I recruited them is, I don't know why I'm opening the same thing here when I'm supposed to be opening this. What they were doing is I prepared a spreadsheet. This is a spreadsheet here. And I assigned them records, yeah? So you notice Matthews Lungo's assigned these things. I don't know where these guys are now. It's been a while. This is a long time ago here. I bumped into some of my former students that was quite nice like that. I bumped into Joe Mwape and a whole bunch of other people. So they were assigned quite a number of things here, but this was Hawkins and stuff, right? So what they were doing is they were told to say the metadata that you see on the platform is wrong. So what you are going to do is you will be repopulating these things by reading the gold standard. The single source of truth is a PDF that was submitted by the student. That thing has the correct things, right? So they would go to the document using this guide, for instance, and then they would be filling in these fields here. All of them, right? These fields here. Now, what I myself was interested in for that particular project, this was done, by the way, it was a couple of years, about 2 years before we embarked on the project that we're discussing right now. But I anticipated that we'd need this information. And in fact, some of these things can be used as labels for other problem sets. Now, what we were interested in when we were working on the automatic generation of metadata is this field here. That's it. This is the gold standard. This is what has the exact details of the, what do you call this? The advisors or the supervisors. Okay? So we did a couple of things here. We extracted data using the ORE, Protocol Object Reuse Exchange, and the Open Archives Initiative for Metadata Harvesting, ideally. Okay. What else are we doing here? As part of data understanding, right? We found ourselves wanting to explore the data, right? If you remember, we said some of the things that you do is you check for anomalies, outliers, null entries, right? Missing values and all those things, right? So we did quite a bit of exploratory data analysis here. The goal is always to ascertain the quality of the data. And we're quite comfortable here with the quality of data coming in from the PDF document itself, because that is prepared by the original author. And the stuff that was labeled, is it? Because the students were hired specifically to label that data, right? So we know they were paying particular attention to, they were doing the right things actually. There may be errors here and there, but for the most part, everything was fine. So that's data understanding. The next stage, which is data preparation, is like, we now need to collect the data, and then we need to, we need to clean it up. We need to transform it if necessary. So at this point, right, we did our initial data collection, but at this point is where we have the scripts that actually pull all the data. So what did we do? We had a script, or we wrote the program. I still have some of these programs, I think, I don't know. Because this has been pending for a while here, it's supposed to be published here, but there's code. I think this was 2024. It's been a while here, wow. I don't know if this is the one here, but maybe it's this, yeah. I know some of these things I was the one writing the scripts or something. So if you go through some of the scripts that we were playing around with here, we were harvesting. Literally, these are the things, right? If you notice, I extracted this data. For instance, these are all PDF documents of the what do you call this? These are all. I can randomly check one of them here. Notice the sizes. These are all manuscripts, PDF manuscripts. But the way the script was written, it was written in such a way that you are, kind of renaming them in a way that will make it a lot easier to stitch this information with the metadata you are harvesting. So this thing that I've randomly opened up here, look at this, right? It's this manuscript here, whatever that is here. And if you are following through with what we were doing last time, right? We can play around with Colab. I don't know if you remember this. We can play around with Colab here to try and get a sense of like how many manuscripts we harvested. Is it how many PDF documents we harvested? Guys, I'm going to, but why now? I'm going to. I'm just going to open up a new thing here so that we try and see if we can inspect the data, right, that was harvested. I mean, I can share the scripts as well so that you can go through this maybe use case example. I don't know if it's going to be useful in helping you understand. So what do we do? This is in Google Drive. I'll come here and I will mount this thing. I don't know why it's taking long here, but I can mount this thing. What I want to do is I want us to gain a sense of like how many things I harvested, right? So I will mount Drive. Hopefully this has mounted. I'll just have to refresh it to see if it's this may take a while. Okay, I've mounted my drive, right? So I'll get to, anyway, I know where that is here. I can use the shebang here, right? And just say get to content and then go to drive, is it? Right? Drive and then go to my drive and then go to teaching something and then go to 2024. I think it's not teaching actually, it's in research. Go to research. I know where this is because I've been using this drive for what, like 9 years or something, you know. And then I'll go to 2024. Let's try and see here if we'll find this. And then I can go to this, is it? This is the file, the folder that I'm interested in. I'm gonna go here and then I'll say, show me what is in here. And then I want to go into dataset. Within dataset, I want to go into, ETDS underbar PDFs, right? I'll just go to /ETDS PDFs. So in here is where I have all of those documents, the PDFs I was talking about, quite a number of them. What did we say? Well, we said, you know what we can do here? We can run bash commands so I can do a WC to count how many there are, right? And I have 4,000. At the time I harvested 4,479 PDFs. Okay, so we get them. And then what we're doing, remember, is we're not interested in the entire manuscript. It's a long document here, hundreds of pages long. What we want is, we want a particular section of the PDF, the acknowledgement section. I remember I had fun working with the students here because they had trouble coming up with a heuristic here. No, the acknowledgement is supposed to be on page 7 according to the guidelines. Because the guidelines, so they were using the guidelines, these guys. The guidelines will state that, look at this. In the guidelines, they will tell you that you're supposed to order your manuscript like this, right? You have your title page, that's 1. You have your copyright, everybody, right? Copyright page 2, declaration 3, abstract 4, acknowledgement 5. So for them initially, right, the initial iteration during business understanding, situation analysis was like, no, what we just have to do is all of these pages that we've downloaded, this 4,479, for all of them we'll just go to page we'll just go to page 5 and just get it out. So in other words, what they were saying is you go to the document, which is this, you get it, and then just extract page 5. So I mean, there are a number of tools you can use, PDF Plumber and stuff. I like PDF TK because I've been using for a long time here. There are wrappers actually for most programming languages. So we're just going to go page 5 here, and then we'll just say this is going to be acknowledgement page or something like that, right? And then you get it. Well, guess what, right? This is not true from all of them because students make mistakes. They do the wrong things, even at a very high level, which is quite sad, really, by the way, right? Fail to follow instructions, but you're a PhD. I don't know what that means here. But this is wrong, for instance, right? You just extracted page 5 and it's wrong, right? It turns out that in some instances, maybe this would probably kind of like work or something for a significant proportion of the documents, but it's not very accurate. So what I had them do was I taught them, because they were struggling with, they struggled with this for almost a month, right? Trying to figure, because, I mean, it's an exam, right? You don't tell students what to do. They have got to figure this out. So they come back and I told them, oh, I mean, if you're lazy, if you're too lazy to come up with a good algorithm or heuristic, just brute force, right? So the brute force approach they took is, for each of these documents here, for each of these documents, you're looping through them one at a time, right? For document 1, get the document, convert, check first page or check first page, convert first page to text and check if the heading is acknowledgement. If it's not, go to second page. If it's not, go to third page, fourth page, fifth page, until you find the page that has the text acknowledgement. When you find that page, that has the text acknowledgement, chop it off. And it turns out that when you're looping, because you keep track of the page numbers, you just use PDFTK for instance, and you just chop it off, and it works surprisingly well, right? So this is what we did, right? So as part of we're explaining data preparation now, right? You cut out the page of interest. So in the case of this new document that I found, because the one I just found doesn't have this, but in the case of this document here, in the case of this document here, the acknowledgement page would be, I don't know if you're counting here, but the acknowledgement page would be, I don't know if it's even dedication, acknowledgement, lecture and plant breeder. This is page 6. So you just go to this thing here and then you say PDFTK, get this, cut 6. Output is going to be that. And you just say ack page or something like that. And true to that, if you open this thing here is going to be acknowledgements, right? And so this is your interest, the page of interest. Colleagues, you know, I'm about to, I've tethered my thing, it's about to think. So what I'm going to do here is I'm just going to switch to my, because my thing, I'm tethering my phone and it's about to go off here. So I'm going to switch to this very useless Wi-Fi where I'm staying here. It's horrible stuff, and hope that it will work or something like that. I hope. Can you see my screen? Oh, beautiful. So it's working. I guess people are out to drink here or something like that. You know, but anyways, I don't know also. Right, so extract this information. Right? But this is only part of the thing we're interested in, because we're interested in the PDF documents here, right? It turns out that when you're playing around with this sort of text, when you're playing around with these sort of documents, ultimately the data has got to be in a certain type of format, right? So, you know, what we did in this particular case, we convert the PDF to text, right? So you get this, and this is a horrible example I've used because it's a scanned document. This is another problem that we had. I don't know if this will work here. We had issues where a lot of documents, where some documents, area documents, were actually scanned documents. And so when you do OCR on scanned documents here, you don't get the result that you want. But what do we do then? As part of data preparation, we now convert this document here, the PDF document, into text. So there's a bit of errors here. Oh, sorry, it's not PDFTK, sorry. I'm supposed to do PDF to text. I don't know what I was doing there. You do that, and then you have, and this didn't work here. I remember we were using Tesseract at the time, actually. This didn't work because it's a scanned document. We had a bit of issues with that. I'm going to pull out something else. This is a scanned document, by the way. This is not text, right? This is scanned. It's not one digital document. So what I'm going to do is I'm going to see if I can find, and usually you can tell if a document was scanned or not by looking at the size, ideally. So I'm looking for something that is significantly smaller in size, like this. Like this. Whew, I hope this will work. Don't know. I don't know if it's even there now. It's downloaded. It's taking a while to download here. I had a bit of trouble with this connection. I've had trouble with this connection. It's not that reliable. But I hope you're getting the point here, the gist. And I can assume that maybe let's assume that the other one I got here is actually acknowledgement text here, but it's not this. It's a PDF document, right? This is born digital, you can see. Assuming this is acknowledgement in text, all we'll do is we do PDF to text, right? And then this thing here, we generate a document here, text file, which is this, right? So if I open this up here, first I can check the type, I guess, right? It's text. If I open it up, I have this text here, this chunk of text, right? Right. So this is what we did, and then ultimately you get this as input, and then you insert it into some. You insert this text here, you read it, and then you insert it into a pandas data frame or something like that. Right, so pretty. You notice here that there's a lot involved, I guess. You probably need to do a little bit of thinking here before you can get to the final end here. Anyways, I don't know if any thoughts. Maybe not. Okay, I can share the code later on that will showcase exactly how this data was read, like pandas data frame and stuff, but it's not really that difficult. I guess what's important to appreciate is if you look at some of the things that we did, right? Like if you look at this chunk of text here, before you can read it here, you need to make sure that you kind of like clean it up, or you reformat it, because guess what? This document here sort of like preserves the formatting rules used in Word, right? Paragraphs and all those things. But what you're interested in is to view this as like a single chunk of text idea, no paragraphs whatsoever. All right, so we did that, and then after we converted to text here, we import the text into a pandas data frame. Now, when you have the text into a pandas data frame, what you begin to notice is that it's going to be messy data, is it? There are full stops, there are commas, and we can use this same document here, the actual acknowledgement page here, this, right? There are full stops, commas, new lines, paragraphs, and all those things, is it? There are these weird things here at the bottom here, page numbers. We're not interested in this, right? So what you do is you clean it up, you pre-process it, and the way we're pre-processing it is we case forward, so we normalize the casing. My preferred way of normalizing the case is to use lowercase. Okay? There are a couple of other things that we did. Now, what you notice, by the way, is that what you notice is that in this particular example, there's nothing like removal of punctuations. Because this is a named entity recognition problem, you're trying to preserve the written speech. It's a completely different problem here. And in fact, what's also interesting is that for some segment of what we were doing in the pipeline, we're not even transforming it to numbers ideally, right? But I thought I'd mention that here. So we just normalize the case and then we proceed like that. Okay, so just showcasing here the data sources, right? The PDF page, acknowledgement page, the metadata from the OIPMH protocol that was used to label the data, if you remember, right? And then the spreadsheet that was used by the data labelers, okay, who were paid money. They were recruited and paid money. And I didn't know that I had this. Actually, I have an outline of how the labeling was done, right? So 8 undergraduate students were trained on how to transcribe the ETDs, right? Documents were downloaded from UNZA and they were even provided with a guide. There you go. Again, I'm just walking through the things that I've just outlined here, right? Where we're saying we we harvested the PDF documents using the OAI ORE protocol, right? So getting all the PDF documents, right? Because we know that the PDF document is a single source of truth here. And then we extract, we splice out the portion of interest in the long document, which is the acknowledgement page here. So the heuristic is simple. It was brute force here. For each PDF manuscript, find where the word acknowledgement is in the header. If you find where the acknowledgement word is in the header, right, you take note of the page number. So we're looking for this. This. By the way, you know, guys, it's quite sad actually, right? Do you know that? PhD students and master's students, some of them fail to spell the word acknowledgement. They were failing, and it took a while for us to figure this out. Right? It's like, why is it that the results, right, are very few? Only to discover that some people, this is supposed to be acknowledgements, right? Some people are just writing acknowledgement. It's like, why? Like this is an example here. The guidelines are telling you, right? Sir, madam, it's acknowledgements, right? Some people are even failing to spell acknowledgement. But I understand anyway, people don't know how to use spell check in your Word document or something like that. But anyways, so we did that, right? It's a very simple heuristic here. And then some other things you do here, if you remember, is I've got to make a decision on whether all the data is going to be used, right? So data selection ideally, right? And then you have cleaning up of the data, pre-processing ideally is what I was talking about, right? So ultimately, when we were preparing the data, this is what we had. This is how I created the pandas data frame, right? So pandas data frame was created in such a way that it had only two fields, right? The text, which is what we're interested in, and the identifier. The identifier for us was important because guess what? This identifier is what was going to be used to link to the gold standard, this spreadsheet. Because it turns out that the spreadsheet, part of what the spreadsheet has or had was the ID. It should be somewhere here. You can't see it here, but maybe I can stretch it here. It's this thing here. So part of this ID, I can copy this, I guess. Part of this chunk of text, which is part of the ID, has those numbers you're seeing. Right? Although we had to do some nifty tricks here. So we were getting this. The last text after the last full colon, right? It's easy to kind of implement this. We're just interested in this, get this, and then replace the / with an underbar, like this. This is the format of the IDs here. Yeah, if you notice here. Okay, so these were used as unique identifiers really to join these two data. So you remember here we have two data sets, right? At some point during data preparation, you merge. You're supposed to merge these things ideally. Anyway, so what we're saying here is like for each observation, you link the identifier with the preprocessed acknowledgement text. That's it. Okay, hope this is making sense here. And then we come to implementation, right? In our case, the implementation was quite simple. It's a named entity recognition problem. So we are interested in identifying names of things in the text. Now, if you're working on a problem that enables you to find entities, right? Named entities, because this solution here is a named entity recognition. You're trying to recognize entities, names of things. So this is what we came up with, and then we initially started off with a rule-based approach, right? Where you're just using rules ideally to kind of like identify named entities, right? And then at a later stage, we used prompt engineering using LLMs. And we just wanted to spice things up and try and find out which approach would be better. Both of them are really helping you identify names. It's just that in the first approach, we're using a rule-based model, right? That does what you're seeing there. And then in the second approach, we're just using an LLM, So I remember we're using the OpenAI API to do this with one of my students. And one of my master students extended what was being done by the fourth years, right? And we were interested in just identifying which method would be better. I believe ultimately the prompt engineering approach was better. If memory serves me right, it's been a while since I looked at this. Okay? It's been a while since I looked at this. All right, so now that you've modeled, it's like you have to evaluate, right? Okay, you have got to evaluate. Now, evaluation really takes a number of different shapes and forms. If you remember our discussion, we said evaluation, for the most part, at a very high level, typically focus on compute resources, which is like efficiency and stuff, and then also effectiveness, right? Relative success of whatever inference model, whatever model that you built here, to what extent is it accurate? In our case, right, we are generating names, we're identifying from text here, we want to identify names of supervisors of people. So it's like, how do we know that what the model is generating is good or not? To what extent is it good? Well, the solution is simple. Remember I said one of the data sets generated was what? It was a labeled data set, right? This. For each of these different documents, we identified who the supervisors were, like this. And so all we were doing here really is we're saying we're going to see what the model generates for this record, for instance, this, and then compare it with the actual thing, which is Dr. Daniel Njovu. How is this accurate? Now, you know, a naive approach, I guess, if you sit there and you don't understand kind of like evaluation metrics for, natural language processing, and in particular, in this particular case, content generation, your immediate intuition will be, well, I'm just going to check, right? Is the text generated equal to the text, the original text? And it turns out that that's wrong, is it? Because, you see, it turns out that when you're generating text, right, if you wanted to generate Lighton's name, right, so it's a Lighton Piri. What if the model generates L Piri or just Piri, right? It doesn't necessarily mean that the model is bad per se, is it? So what you do is you use techniques that look at like how bad the text is compared with the original ideally. You just don't do a direct match, okay? So in our case, the evaluation, I'm going to go to evaluation here. We used the so-called blue scores, right? There are other alternatives. These are standard metrics when you're evaluating text here. There's like so-called rouge score, and stuff. I don't know if we get to discuss. Some of you, I think, the people that are doing AI, I believe, I don't know if you're doing this in soft computing, we don't know. But it turns out that there are so-called, I'll just, text generation. So rouge, you have these scores, right? And what you're doing is you're getting the text generated by the model, and then you're using it to comparing it with the original, right? I don't know, we can talk about this during evaluation because text has become an integral part of what we do. I don't know. Maybe we can talk about it, maybe not. I don't know. But there are a number of evaluation techniques. I don't know why that is. I don't know why that is taking a long time here. Anyway, we can discuss this if people are interested. Maybe we can look at some of these metrics, right, at a later stage during our discussion of evaluation, I guess. I don't know. If that makes sense. But so you wouldn't be using metrics like precision and stuff, right? You'll be using other different things here. Anyways, so we the key thing here is the metric we're using here is the blue scope. So what this is showing you here is the proportion out of the things that we were evaluating. By the way, 1 is good, 0 is bad, right? It's like 0 is almost like there's no match at all, if that makes sense, right? So we see that the significant proportion of things here were a direct match, which is a good thing. Which was a good thing, I guess. I don't know. Okay, so we evaluated and then you deploy, right? So the deployment here can be done in so many different ways. You can build a plugin to be, remember we're trying to solve a simple problem here. I don't know if people have kept track of where we're coming from. We are saying the problem is that the IR has things that are not properly identified. So how do we inject metadata? Well, you can build a plugin, or you can, I've studied DSpace for a long time, these sort of tools like DSpace, ePrints, Omeka. At some point they were part of my life here. So one of the things that you can do, it turns out, is you can take advantage of batch ingestion, right? So you prepare your modified metadata and then you batch ingest. DSpace has what's called a simple archive format. SAF, something that allows you to import data, so you can manually construct these things. It's not a problem. All right. I don't know if there are any thoughts or questions about this. I hope this is a nice way of demonstrating, how you would build a data mining pipeline using the CRISP-DM methodology. I mean, if you are deciding to use SEMA and KDD, the changes that you'd make they wouldn't really be substantial, right? Just minimal changes. The key activities would pretty much be the same. Is this fine? Can you still hear me, by the way? I hope people can hear me here. Okay. Beautiful stuff. So, I don't know why I'm using, I'm using the same, it's still text, but maybe it's different here, I don't know. the next thing here is classifying ETDs, is it? ETD classification, right? And I'm going to tell you something else here. It's still a metadata issue. We obsess a lot about some problems, by the way, because access to data is relatively easier, okay? Very easy, actually. Yeah. So anyway, in this particular problem, right, it's like the issue of the repository, when they're depositing manuscripts by masters and PhD students. There are a lot of masters and PhD students. By the way, we conducted a study. It was like kind of like a baseline study. My students conducted interviews with people from the library, try and understand, right? How do they actually upload these things? And they discovered things that shocked them. Like, no, sir, we found out that it can take as long as 30 minutes to prepare metadata and then upload the ETD into the repository, right? It's a very tedious process. But that's not sustainable, right? And then they discovered, well, currently the library only has 2 people that have been tasked to do this. It's like 2, right? And they don't just upload ETDs, by the way. They're uploading, if Lighton publishes a conference paper, that paper is going to go into the repository. Journal article in the repository. Book chapter in the repository. Book in the repository. You know, it's crazy like that. So the issue here is, you know, can we automate the process of depositing content in the repository? And if you think about it, right, it becomes a document classification type of problem. I don't know, well, maybe because we haven't discussed this here, but you're classifying documents, right? Because what these people are doing when they're uploading content here is generate metadata. What is the title? Look at this. What is the title? Who is the author? When was it published? Right? What's the abstract? Who is the supervisor? what is a department, what is a school. Now what we discovered was that, so there's that part here, right, where we're trying to automate the process of depositing content in the repository, but also there's a bit of misclassification. We discovered that when it comes to theses and dissertations at the UNZA, for instance, everything in NS is just dumped in NS. We don't know what is computer science, we don't know what is engineering. So it's like, can we solve that problem? Can we identify kind of like the department that a particular thesis and dissertation belongs to? The other part of the problem, I think I explained it in use case 3, I don't know, is the subject headings, right? If you have a dissertation, let's say one that has been prepared from the Department of Computing and Informatics, how do we know which subjects to associate it with? And then finally, a manuscript, right, can be associated with a PhD or a master's, a thesis or a dissertation. And it turns out that the current things in the repository are not distinguished like that. And so the thinking was, can we course correct this? How can we fix this? Well, we can build a model that will be able to tell us, say, this dissertation here is PhD or master's, right? Or a thesis or a dissertation. So, but PhD or master's. Okay. Anyway, so there's some reasons why this problem was important, or I think is still important. UNZA hasn't implemented self-archiving. This problem, by the way, when you have a problem, you want to acknowledge the fact that you just don't, it's not all the time that a problem can be solved using AI. This is a trap a lot of people fall in, right? No, we have the problem. I was chatting to some students who they gave up and decided to choose a different supervisor, right? No, we are trying to build an AI model that's going to let people know which equipment is available not in the Department of Computer Science. And I'm looking at them and I'm like, how much equipment do we have, right? Are you seriously telling me that you want to carve out something like that as a machine learning problem? Why? Right? You're working with like less than 100 data points, less than 50 data points. What's the point of doing that? So in some instances, there could be a simpler solution that doesn't necessarily have to involve data mining, is what I'm trying to say, right? Data mining will probably be overkill ideally. But anyways, a solution to some of these problems that I'm explaining is self-archiving. So what the UNZA has done with this repository is you can create a profile with an academic member of staff. I have a profile myself. Boom, surprise, surprise. I can log in. I can upload things myself. That's the easiest way of doing this. You're pushing the problem to the owners of this content. But this is hard, it turns out. The issue of self-archiving is so hard that a lot of people, if you just have written about this, if you just search in Google Scholar, self-archiving in institutional repositories, you'll be shocked and amazed as how much of this has been written about. But I don't know, self-archiving. Not self-archiving in institutional repositories, right? Quite a bit of content here. Motivations of faculty self-archiving in institutional repositories. Assessment of self-archiving in institutional repositories. Crazy like that. But anyways, so this is one solution. But it turns out that there's no self-archiving at UNZA in the classical sense, right? People don't know. And even if they knew, it would be difficult here. There are these huge time gaps. So it's a motivation, right? So you find that right now the UNZA is still uploading things that were submitted last year. People that graduated last May. They haven't finished adding those things. They're still adding them. They're still adding them. In fact, one way of knowing is if you go to the UNZA repository like this, and then you say by issue, and then you kind of like organize this in descending order. You notice that the most recent thing that they've uploaded, I don't know if they uploaded anything maybe they've changed now. I don't know if they've uploaded anything in 2026 here. But you notice that they're still uploading things, ETDs from last year, right? Still work in progress. Maybe they have finished, I don't know, this is from, we can check this. This is the most recent item, and this looks like it is a dissertation. I don't know whose idea it was to implement this. I hate this, right? This new Chrome feature here, it's like you can split things, stupid things that people, okay, maybe I'm just old school like that. Right, you find that they're still uploading things. So there are these huge time gaps, right? Huge time gaps, ideally. Huge time gaps. That's the other problem. And then there's inconsistencies during classification. You find that something is supposed to be an ETD, but it's been dumped into a conferences container. That's wrong, right? Misclassification. So to aid with this, we said we can build models, right? Models that will be able to automatically classify things so that you reduce the errors. The issue here is not to replace people's jobs, but to reduce on the amount of errors and inconsistencies. Yeah? So a solution here is we're saying we use classical machine learning, supervised machine learning to be specific, to build classification models that will be able to classify a given object, like it could be a PDF document. You classify this as being a master's or PhD, a thesis or a dissertation. What else? Get the ETD and figure out the subjects associated with the ETD. What else? Get the ETD and figure out which collection, which community it should be deposited into. And all of this is being done to reduce the amount of time it takes. Remember I said that some group of students I worked with discovered that it would take maybe 15 to 30 minutes to deposit a single object, right? It's like if you're automating some of these workflows here, what you're doing is you're reducing that time. Maybe to reduce it to 5 minutes or 10 minutes, which is good, right? You're improving the efficiency, is it? Ideally. Okay, so the question here is how exactly did we implement these models, right? Again, first step is business understanding, right? What is the goal? The goal here is one to automatically classify the collection associated with the object, the type of ETD, and the subject headings. That's it. That's the goal, data mining goal here. We conducted a situation analysis. This is all documented, by the way. Towards the end of this slide deck, you have links to publications that have this information in detail. A number of these things here have come out of fourth year capstone project reports, but also master's dissertations. I probably have maybe 2 or 3 master's dissertations based on this sort of work here. We do quite a bit of stuff tied to this, right? Anyway, so situation analysis, there were interviews that were conducted with stakeholders, you know. Conducted workshops. It was quite fun here. All of this is documented. And then we come up with a plan, right? Again, project plan here is pretty trivial. If you're looking for project plans, because the work we did here is tied to a number of sub-projects, there are different work plans. So if you look at the proposal documents, you have details of the plans that were associated with these projects, ideally. But you have a plan that will signal how long it's going to take to work on the project itself. And then data understanding, right? So we identify the data sources, right? In this particular case, we are building classifiers. It has got to be labeled. When we were working on this, right, we didn't have resources to hire human beings to label data. So what did we do? For us to train a model, we need labeled data. We went out there and we harvested data using Dublin Core. Okay? Anyways, so we did that in terms of the data. And then, so we do an initial data extraction. Sorry about the noise here. It's close to Tunya Road or something like that. Anyway, so we harvest the data using OIPMH and OIRPMH stuff. We do our usual EDA, exploratory data analysis. More on this, we have a detailed lecture series tied to this. The goal is to assess the quality of the data. Data preparation. This is a classic case here because the input, I'll showcase this right now. The input features we're using were actually textual data. So for some models, we're using, if not all of them actually, the title and the abstract, right? The title is text, abstract is text. Because it's text, when you're processing text, you remember the preprocessing steps associated with textual content. Deduplicate, obviously, right? Handle now values, but what else? Case forward, right? You normalize the case. You remove stop words. You stem. You remove punctuations, right? You remove numbers, right? You do a whole bunch of things here. Anyways, so we applied common text preprocessing techniques, and just showcasing the data sources here. We were using maybe I should mention this in terms of the features. Yeah, when I said PDF manuscripts, we did a lot of crazy things here when identifying the handcrafted features here. We realized that the title page itself, all the text on the title page can be used as a feature. Something else that we realized we could use as a feature is the entire manuscript, specifically the number of pages, the length of pages, how many pages does it have, right? And then the title, and then the abstract. So quite a number of features. I'll explain some of these things just now. Okay. So just showcasing the data sources, and just indicating exactly how this was extracted, how this data was extracted, right? So textual content mined from PDF manuscripts, like the cover page, for instance, right? And then you're looking at textual content mined from metadata, like the title and the abstract was mined from stuff extracted using OIPMH protocol ADI. Okay, just showcasing the OIPMH protocol, how it appears. I think I already showcased this when I went to the UNZA repository. Okay, and we were doing this here to help with labeling. This is automated labeling, ideally. In a root setting, you're better off using human beings, but sometimes when you don't have human beings, you can automate the process. In fact, this was pre-LLM, before the rise of LLMs, and I'm pretty certain most of the things we're doing can be done better using these large language models, right? So life has become a lot easier here. We label, right? And then in terms of where were we getting the cover page, same process, OAI, ORE, so Object Reuse Exchange Protocol, right? We're interested in downloading the PDF and getting the first page. This was easy because for us to get the cover page, it's like you're just getting the first page. Get the document, cut out the first page. So doing the same thing I was doing here, but in this particular case, PDF TK, like this, and then cut 1-1, cut 1-1, cut 1-1, so that you get the page. Cut 1-1, you get the first page. It's pretty straightforward. And this is what we ended up with. I don't know if I still have access to, I think I still have these things here. Most of these things I use, most of these things we're using Colab and dumping these things on Google Docs, and Google Drive really. So I'm pretty sure if I was to check for this, I'll be able to find them, unless if I deleted them. Booyah! Thank you very much. It's here. This was in 2019, if you notice, right? So if I go here, if I go in here, I'll have access to all of these cover pages that we were extracting. You know, it was quite fun here. Anyways, that's neither here nor there. Right, so just showcasing the cover pages, and then guess what? Besides the cover pages, we also wanted, or we identified, the number of pages, and we discovered the number of pages would be a potential feature because the guidelines, they tell you that when you are preparing a master's thesis or dissertation, observe, if you are in your case, you guys, you are doing master's by coursework and dissertation, you are going to be expected to submit a manuscript which should be anywhere between 20,000 and 35,000 words. Now, one of the things that they'll tell you here is they'll tell you, is it 1.5 spacing or something? I can't remember. But it turns out that this 85,000 divided by That's 500 pages. 500 words rather. Sorry, 35, 1, 2, 3, divided by 500. I don't know where this is coming from, the 70 pages here, but this is a bit off here. It translates to a certain number of pages, right? I think this is wrong here. I don't know what this is here. Masters by, maybe they've changed things here. It used to be 60,000, I think, divided by 500. Yeah, 120. So previously, the old guidelines to be like your manuscript, if you're a master's student, must not go beyond 120 pages. So for us, right, that's like a key. It's a feature, right? It will help us. It will help us build a model that tells you whether something is an ETD. Is a thesis or a dissertation, master's or PhD, right? So what we did really was, again, we used well, it's PDF info. I guess you can use something like PDF info here, right? So what PDF info does is it gives you access, and you don't have to use PDF info. There are a number of tools, but it gave us access to this. So for each of the documents, and you can run like a script here, right? To say for each of these documents here, run PDF info on it, not the cover page, but the entire document, and then strip out, and this is not difficult here. For this, it renders a lot of stuff, right? It's just grep for pages or something like that, right? And then get the last chunk of text after the full colon. You can splice it up, right? Split it in essence. And then you get the 136, ideally. So ultimately, we're extracting this, right? Information, number of pages. And then in terms of the coming up with the subject headings, we used transfer learning, right? And we demonstrated this using, I think it's something from the health sector or something like that. So, which is why we used PubMed to extract data that was already available, and we labeled it, and we used that for training ideally, and then applied it to the UNZA repository. Because it doesn't matter if research which is health related is in the UNZA repository or in PubMed, it's still health research, right? So you can train a model based on data from elsewhere, and then you apply it in the UNZA repository. That's called transfer learning ideally. Okay? And then we do the data selection, and when we clean up, right? We also do the transformation here. Now it turns out that this is different from the previous example, because in here, the input text here, we are building classifiers. So most of the estimators that we're going to be introducing you to here, it turns out that they expect the input to be in a certain format, numbers ideally, right? So we need to transform. So here's the thing. For page numbers, it's already a number. The only transformation is we are scaling or something, but using it the way it is fine, as 136 in this particular case, right? But for text, titles and abstract and the entire text on the cover page, it turns out that it needs to be transformed. And so what we did was we used popular text transformation techniques. Typically, you can get away with, there are more modern transformation techniques, but you can get away with TF-IDF and bag of words mode or something. You can do fancy things like continuous bag of words and stuff, but usually, the more traditional approaches are just fine. They work just fine. You just have to tweak them so that you figure out the n-grams to use, whether to use unigrams, trigrams, or bigrams and stuff, and then there are certain other hyperparameters that you'd have to tweak here. But we'll discuss that when we look at data transformation. Anyway, so the goal was to transform the text previously like this into numbers like this. So it's just like a huge vector. There's something interesting about text transformation, right? So using a vocabulary associated with the entire corpus, your universe of documents that you're working with, you identify all unique words. The all unique words here are the ones that you're seeing here: Abbas, Academ, Zambia Nation, Zambian there, Zambia Object, Zambia Study, and stuff, right? And then you're building this vector. For each row is a document or a record. You're saying in this record, the first record, the text Zambian there is there. The text Zambian object is there. The text Zambia use is there, right? If you notice here, that's the whole point. So we had to do data transformation, and we'll have a discussion of transformation techniques here, like when we apply one-hot encoding, you know, how we scale images and stuff, right? It's part of data transformation. So did that, and then we do the modeling, is it? We're building the classifiers. Now we're building 3 types of classifiers here. You may not know this already, but I'm going to say it nonetheless. By the way, all of this is available in a paper that I authored myself. You know, I have a confession to make. I did this every now and then when I have time. I do things myself. It's expected in academia, right? You're supposed to demonstrate that you're capable of conducting independent research, right? So you get more points when you do things yourself. So I have some single authored papers. Occasionally, I'll do this when I have an idea that I anticipate is going to spawn off a number of different, you know, sub-projects, right, for future students. So I'll write something that will set the stage for what's going to happen here. So this stuff that I'm talking about, colleagues, is available apparently in this paper called it's been a while, actually, years since I did this. In this paper called wow, it's been many years. You know, something is esoteric, then that people, this thing here, single authored paper, automatic classification of kind of like ETDs or something. It's from 2021. So did quite a bit of at the time, I mean, before the rise of KESA, right? This was like 2019 when I was doing this. So it's such a big deal here. But now, most of the things, if you know what you're doing, you can pretty much do it here, right? So in here, you'll find details about what I'm talking about right now. In fact, this is our reading list. Please, if you want to read and understand this. Yeah, so we're building these models here, 3 types of models. Okay. So the goal here was to build a model that tells you whether it's an ETD or not. That's a binary classifier, yes or no. Is it ETD? Yes, no, 1 or 0. And also a model that tells you which class. Is this natural sciences? Is this education? Is this engineering? Is this mines? Is this medicine? Is this public health? Is this nursing? Multi-class classification. We'll talk about these things. And then the subjects. Is this document to do with cholera, malaria, paracetamol? That's multi-label, right? So you can attach a number of labels to something, right? So 3 types of models that we implemented, and all those details and how they were implemented. And I think I did a implementation of a thing as well. This is quite detailed, actually. I think I outlined how this was deployed as well, right? So this is how you typically would evaluate multi-class and stuff. But anyways, so we did this, and then we're evaluating, right? Now the thing about evaluating, you know, supervised machine learning models here is like they're predefined metrics or ways of evaluating these things, right? If it's a binary classifier, I say, well, you need a row curve, you know, accuracy, precision, and all those things. What are you evaluating? Well, we want to see which estimator is ideal, which is this thing on the far right, right? You know, you have like your row curve, and the largest area under the curve is what you want. What you have on the far left here is what's called a confusion matrix, right? And you typically focus on the diagonal, right? Numbers there. They're telling us the accuracy associated with each of the different classes. If you read the paper, you'll notice that ED is education, MD is medicine, NS natural sciences, AG agric, HS humanities and social sciences, LW law, VM vet medicine, EG engineering, MN mines, LB what the hell is the LB? I've forgotten. ID is IDE. What is LB though? I don't know. Can't be law. Law is LW. Up, I don't know. I think it should be here though. LB. I don't know if LB is. It's been such a long time that I've even forgotten what LB is. Library. Ooh, wow. Library, LB. So there's this nice table that even has things here. Christ. Okay. And deployment, right? So what I did with deployment here is build web services. I don't know if the web services are still functional. So if you go to my GitHub repository, just search for Lighton Piri, you will find things, APIs that you can actually query. I think they're still running, I believe. I don't know if Heroku put it down here, but I created a Heroku app that allows you to push a title or a title and an abstract, and then it tells you, right? This is medicine. This is a master's or something like that. If that makes sense. Deployment is easy here. So you should go to GitHub, Lighton Piri, ED, auto classifier, and you'll find details about these things here. I'm gonna pause here and kind of maybe try and find out if there are questions. I don't know if this is enough in terms of examples, but maybe one last example I normally use, and then we can let it go here. That should be sufficient for you to have an appreciation of what all of this is all about. What I just want to draw attention to, in as much as the two use cases I'm just from talking about are somewhat linked because the data sets, sources of data are more or less the same, but the idea is the same, right? The things that you do is the same. And this is what I was telling my colleagues yesterday during our training session. I was telling them when Professor Kaleji was doing the deep learning session, he was using the Iris dataset, right? Remember the Iris dataset, guys? I told you that as you are playing around with GitHub, not GitHub, sorry. As you are playing around with, I told you this, when you're playing around with these packages that we looked at, I told you to say one of the things that you can do is you can play around with sklearn, right? Which we installed together actually. And in sklearn, you have access to toy data sets. You want to stay away from these things. You want to learn the end-to-end process, not just fake it and start halfway through. If you start using these data sets here, these things, these, right? Iris dataset, the digits dataset. I know Professor Kaleji used, when he was looking at the classical machine learning, he was using the Iris dataset, right? Remember those 4 features? Petal length and stuff. And then he also used the digits dataset to demonstrate ideas behind deep learning. But anyways, so the point I'm going to put across here is that it doesn't matter, I guess, low digits. It doesn't matter what sort of data set you are using, right? The idea is the same, whether you're working with images, text, sound, don't know what else, video. The idea is the same. But here's another project of ours, right? We were interested in trying to figure out if we could identify students at risk of failing. And the motivation here is simple. The problem is simple. The failure rate in a course called Computer Systems and Architecture was quite high. Now, if you've done computer science, computing, and you did computer architecture, computer systems, you agree with me that some of those things, abstract things, are hard to understand, right? A lot of students who perform poorly like that. And for us, it was a huge concern because a number of students that do this course have loans. So government is investing massive amounts of money, right? Huge quantities of resources. And so our argument is, can we change the status quo so that we reduce the number of students failing? So that they pay back the money, right? You go and find jobs, I guess, and you start paying back. I hope you guys are not cheating here, but you've started paying. Guys, maybe thumbs up, those of you that had loans. How many have started, how many have started paying back the loans? How many have salaries being deducted? Thumbs up. I'm just curious here. What? Okay, yeah. That's good. I think we should report some of you if you haven't yet started paying. You must be proud of the fact that you're paying tax and all those things, right? You see the value of tax, is it? Now that you're paying that pay thing here, I'm sure you're saying, oh, I'm contributing towards giving these people loans or something. I don't know if this thing is a Ponzi scheme, right? Well, I'm glad I won't be around when it collapses myself, I guess. But So the motivation here is we want to reduce the failure rate. Now, we're not building a model that's going to stop people from failing. No. But our goal to solve this problem, right? A lot of students are failing. And we're sitting there like, what are we going to do? Well, it's like, we're going to come up with a solution that will tell us the students that are more likely to fail. Now, when we know which students are more likely to fail, what we can do then is, I'm going to pause here and check if I'm still online here. For some weird reason on my mobile device, I see here. I do apologize. I think my connection is has gone kaput here. So I'll just change. I just realized on my, I don't know what's happening here. Is it back? I wonder. Let me see here. Or should I just switch to my personal? I'm just going to switch to my personal kind of hotspot here. I hope. Yeah. So you couldn't. I don't know if you can hear me. Can you hear me now? Yeah. Let me see if I can rejoin here. I can't see anything. His network, they're saying. Yeah, it's my network. Let me see if I can rejoin here. I don't know why it's taking a while for me to join, but hopefully. Yeah, sorry about that, colleagues. You know, I had a bit of an issue with my. Can you hear me now? I hope. Hello, can you hear me now? Okay, thanks. Yeah, so I had a bit of an issue with my connection.
Yes.
Beautiful, thank you very much.
Yes, Dr. Pierre.
Yeah, so I had a bit of an issue. Wonderful stuff. So we're going to continue. Sorry about that. So I was talking about motivation for doing this this use case, right? So huge failure rate. Now I want to stress here, we're not building a model that's going to say we will prevent students from failing. That's not what the model does, right? What the model does is it actually what the model does is it tells you sorry about that, another disruption. Somebody was trying to copy because I'm tethering my phone here. It's able to tell you to say these students are more likely to fail. Now the idea here is simple. If you're able to figure out that a student is more likely to fail, you can come up with an intervention. And in the case, in my case, I taught this course for a very long time, right? 2018, 2019, 2020, 2021, 2022, I think all the way up to 2023, 2024, right? So for quite a number of years. And I'd figured out patterns, right? What worked, what didn't work. I guess you'd say the performance of students and all those things, right? So anyways, the goal was to build a model that tells you this student is more likely to fail, and if they're more likely to fail, you come up with an intervention like you tell the tutor. Create a tutorial group for these particular students and focus on these key areas. Or you have additional contact hours for those particular struggling students. Or you talk to them, you talk to the students, right? And you advise them, you need to do ABCD or something. So the goal here was to build a model, right? So all of these, by the way, this diagram here shows you the performance of students in assessments, quizzes, and tests, and tests as well. It should be a final exam as well, but in tests, the performance is quite bad here, right? So business understanding, right? Our goal was to monitor student performance, right? To prevent poor performance. That's the main goal here for the project. And in terms of the data mining kind of objective, it was to identify those who are at risk of performing poorly. Okay, what comes next was not really part of the scope of the problem. You know, so in terms of situation analysis, we're interested in trying to figure out exactly how, you know, students at risk of failing were identified. And I'll be the first one to tell you that there was no mechanism in place, right? It's just like you only be able to figure out who is more likely to fail maybe after test 2, right? After they write the first test and you are in semester 2 here and you realize this is horrible here. No matter how hard they work here, this person is going to fail or something. And that's what we're trying to prevent, right? We don't want to be reactive, but we want to be proactive ideally. Okay, so we prepared an overall project plan. By the way, there's a whole capstone project. It is on our research group website. Detailed, very, very detailed. I'm very happy with what those guys did. So if you go under capstone projects here, you'll find stuff that Ivy, goodness, it was a long time ago, such a long time ago. It's been a while. Some of these people I should call them to find out. Ivy, Mtune, Pungwa, and Siababa, and Bidon. Some of these people have been in touch and stuff. So you'll find it's 2021 work here. We did a lot here. There's a lot of, I had them do a lot of work here, right? Really proud of what we did. Very systematic. If you look at the science behind what we did here, quite comprehensive like that. Okay. Anyways, so there's a timeline, right? Which is pretty intuitive here, and then we're identifying the sources, right? It's like what sources are we using? Well, quite a number of data sources, right? Compare and contrast. By the way, I hope you can still hear me and you can still see my screen. For some reason I can't see it on my mobile device. Thumbs up if you can still see my screen, just fine. Okay, that's fine. It's probably just my mobile device. Oh, there we go. I can see it now. Yeah, so the data sources here are quite substantial here. So things that I was compiling myself, scores, right? I'm very meticulous when I'm compiling scores for assessment. Demographic details for students, right? So we go to SIS, we pull that information. Subjective information coming in from students in regards to their experience, right? Because this is like an elementary type of course, would ask them questions like, have you had prior computer science or computing training, right? Interaction logs, you know, tutorial attendance, lecture attendance, and all those things. Now, if you read the paper, if you read the report, you notice that all of these things are mapped onto aspects, right? Aspects that research seems to suggest influence the performance of students. Like one of those aspects is engagement, right? If a student does not engage with a course, it's likely that they'll fail or they'll perform poorly. Now, our task, right? So we go out there and we did kind of like some baseline studies to try and figure out what factors affect or influence performance. Attendance, engagement, workload, right? Prior experience and all those things. And so the task at hand, and this was slightly difficult here, is like you sit down here and you figure out what data sources can we use that are going to enable us to measure engagement. Some of these are straightforward, like attendance, right? I mean, you can easily do that, but engagement, right? How about past experience? Where are we going to get this information here? Anyways, I'm going to do a preliminary data collection here, right? I wanted to showcase so we did the usual EDA exercise, exploratory data analysis and stuff, right? Just trying to make mention here of the fact that some of the data sources are missing details because like lecture attendance was not very meticulous. What I do now is for all undergraduate courses that I teach, if it's an in-person class, I go there with a register, right? And I scan it, transcribe it like that, because I know in the future I'm probably going to have to experiment some of these things. This is specific to a course, right? One course, it's a first year course. What we are seeing here may be different for a fourth year course, a different course in a different discipline or something. The markers may be different, you know, so you want to, you know, make sure that you don't really generalize things here. But anyways, in terms of the data sources, I'm just showcasing the data sources for assessment results. These are things that I compile myself, so every time there's an assessment, I'll meticulously compile it. In fact, for this particular course, I was so detailed that I would associate topics as well, although we didn't go down to that level of detail. So it's like, if you look at the performance is in more abstract topics like, I guess, MIPS, the MIPS instruction set architecture, right? Goes way ahead of students' heads here, right? It's like, it's difficult to understand, to wrap your head around ideas and concepts of how a computer calculates or computes or executes instructions or something like that, right? But anyways, so there's this data set, and it looks something like this, right? So you have details of the students, the scores that they got. This is for the quiz, right? For like tests, it would be slightly different because there are more questions. A quiz would be like some assessment that they write in 10, maybe 15 minutes ideally. Okay. What else? LMS or Moodle interaction logs. I think I already showcased this, right? Where I can show it again, I guess. Where I said Moodle is such a rich, has such a rich data set, right? I teach computer graphics course here. If I go in here, right, you notice that if I go under logs, if I just get all of the logs for now, look at what's happening here, right? I know, but why here? Which person is accessing content on the site, what time they're accessing content. This was today at 17:45. This person was watching a recorded lecture, right? This person is probably behind here. They're preparing for a quiz. There's a quiz next week, probably, right? It's all Moses Kalwa, and then there's Dali. So here, right? They are all going through lecture series number 5 because we have a quiz next Friday, not this Friday, but next Friday or something. But this is so detailed, right? You notice that multiple records for the same person for the same day, but different times or something. If you were to extract this information, and I can extract it for you right now so that you see, I'll extract it as a CSV just now, and then I will, guys, you see now, maybe we can even use, maybe we can use even pandas here, because I have no idea. This is quite lengthy, right? You see pages here. So it's a lot of data here. What you're seeing here is just for 2 days, from the 17th of March. This would be nice. Why can't we do that, guys? I'm going to go in Playground, and then I'm going to go to logs, blah, blah, blah. Wow. It 1.8 like that. I'm just going to rename this to this. It's going to be a lot easier that way. This is the one which has data mining environment, so I'll just move the stuff that is in here to here. Then we can do the usual import pandas. I don't even know what is here, right? Playground. Comma should be fine, I guess. So import pandas as PD. Graphics. Or I'll call this CSV 4505 is equal to pd.read CSV. If you remember this, right? Be a nice way of boom. Let's see if this has dot columns. Oh, there we go. It's done, right? So this is fine. So how many records do we have? Well, shape, we said. Oh my goodness, 6,718 records. But I have a sneaking suspicion it persists from last year as well, also. So one of the things I would have to do here is I would have to probably, I would have to, I don't know if I can get the time and see here. I would have to extract just things that have, I wonder if we can can we do this, colleagues? 2, 4, 6, 7, 8. We just do 8. That's beautiful. So if we just do 8 like that, and then you notice there's also 2000. There's 2025 at the end there, but I think most of them are from 2026 actually. If you notice, the last I think we can do a head, I guess. Time dot head, is it? And tail. Yeah, it's okay. It's 2026. The only records for 2025 are 2 of them, so it's fine. You don't have to filter. I want to showcase that you can also filter. But you notice here, right? Just the logs for this year alone, 6,000, right? Entries. That's rich data set right there. And these are the details of these things. If you look at the columns here, right? You know, there's the event types, the event name, there's the IP address. So you can do fancy things like see if there's an influence on the type of device people are accessing, you know, event context. It's crazy. Are they from home? Are they using the UNZA network, EduROM and stuff? Because if you have the IP address, I guess, I don't know. I think you can do this also. Maybe not. Probably. I don't know. I haven't really explored this. I don't know. I don't know. All right, that's neither here nor there. So what I was trying to say is the Moodle logs is somewhere else where data we're extracting here, right? What else? There's a survey, right? So for this particular course, it's your course, I'll do a preliminary survey to find out the background of these first year students. This is like their first time at UNZA. I don't really care so much about, you know, these senior years, like second, third, you know, fourth year. It's not an issue, right? And this instrument, it turns out, it was crafted in such a way that it would elicit information about their experience working with computers, their motivation. You know, it's fun actually. What you notice when I share this data set is it will be fun to build maybe a model that looks at the motivation of students, right? Do we see students that were motivated to do this course performing better than those that perhaps were just forced to do the course, something like that? I don't know. Maybe not here. So we do the usual here. We select the data required, we clean it up, right? We reconstruct the data, we merge. Now this is where it becomes interesting, merging, right? Why? Because you have information coming in from all sorts of different sources. So you've got to merge this information. I'm gonna let you in on something here. You see, guys, but where is it now? I don't know where that thing is here, but I wish I had it. I was going to showcase. I'll share it with you at a later stage. I have rich data sets here that I'm planning to actually publish a dataset paper or something. I just haven't had chance to do this, right? But I want for you to look at the consolidated dataset just to gain an appreciation, right? So I have datasets to do with demographics. This is from SIS, issues to do with workload. In fact, maybe what I would do here, not maybe, what I want to do is to showcase to you, because this is one example where merging becomes extremely important, right? And then I have consolidated results as well. And then I want the entire, you know, I'm just gonna open. Why am I not opening them here? I'm downloading them. What is that now? I don't know if this is the one. Wow, nope. There's a preliminary survey as well. This will be interesting to see. I just need to order this by date here. The preliminary survey would be interesting to see, maybe not. So I have demographics. I'm just going to go at the beginning here. I'll have this. I have demographics. I have assessment scores. I have workload. So what I'm showcasing here is the fact that the sources of data for all of these different data sets are different, right? It's the same course registers and stuff. It's a kind of like the same thing that we're doing, but the sources of information are different. The idea here is that ultimately, at some point, you need to merge the data sets. You need to merge something like this. I don't know if you can see here. Something like this. So these are masked, right? You won't know who they are. Some of the students that are enrolled into this course, by the way, have their details in here. So probably Lloyd Mwansa's details are in here. Ms. Pule's details are probably in here, but maybe they'll be able to identify themselves. But anyway, so I don't know why this is taking a while here. You notice if this thing is like freezing here because the data set is it's not that huge here, but this is just demographics, right? This is from SIS. This kind of showcases to me or to us that has personal identifying information. I wanted this. This has been masked. So what you see as student names here, I went through a process of I went to Facebook and I used comments. I used details of people that comment on Facebook on Zambian Watchdog. I got those names and then used them to replace original names. And the student IDs here, you notice here, this is just a SHA-1 hash or something like that. But anyways, so I wanted to showcase this, but this thing is not, it's freezing or something. I wanted to showcase the fact that this data set is quite huge. Quite huge, quite substantial. But it's created by stringing together these things. Right? So we string together data from here. I know why that thing is from here. This I need to close. From here. Right? And all of these are not anonymized. I need to access stuff which is anonymized or something like that. But anyways, the key thing here is that this thing is not responding. I have no idea why. But the key thing is that at some point you need to, and there we go, it's working now. At some point, you need to string together data coming in from these different sources. By the way, the reason why this is slow is when I'm using Google Sheets, for instance, I use a whole bunch of formulas where I'm importing ranges from external files. So some of the information in here is coming from external files, right? Which perhaps is not really the best of ideas here. But you notice here, we string together this, right? Together like that. Okay. Anyways, so after the evaluation, we then deploy, right? So the deployment, simple deployment is available in the report, the Capstone project report. Nothing complex about it. The usual stuff. You create a web service, right? Using Flask, perhaps. I don't know what, maybe some other fancy framework or something. And then you build an interface. You use the interface. Use the web service or the API to interface the model with the UI, and then you are done like that. Okay. The other thing here, I'm just going to add it as a reading list for you. It would be nice for you to try and figure things out. There's a paper, right, that we have authored, and that paper can be accessed if I can just find I'm just going to see if I can find I want you to go through the journal article that is based on that, actually, which is this. So this is going to be our reading list: controlled vocabularies in digital libraries, challenges and solutions for increased visibility here. So that's our reading list. For you to understand the last example here. Okay. Yeah, and really, you notice that all of these things, right, are the same. You know, I was talking to a very important person from NAPSA here, and he's invited me to go and see him. They're looking at fraud detection. You know, apparently these partial withdrawals here, some people have taken advantage of that, and they're doing all sorts of strange things here, right? Impersonating certain people, right? Forging NRCs and stuff. So they're trying to see if they can build models for doing that, or fraud detection ideally, right? At the beginning, I don't know if you remember, I'd mentioned that I'm supposed to be working with the awesome Dr. Mdenda from physics. He's an expert when it comes to solar energy. You know, so we're trying to see if we can figure out ways of automatically detecting which solar panels are problematic, are faulty, or need to be replaced and stuff. You know, so the idea here is, irrespective of what you're doing, right? Whether you're working with images, that's images, by the way. If I was to throw in the pothole detection problem, if you remember at the very beginning of class, I think I had said that.
So when I run this, the way our mode
I
actually
had
works
said
is
that,
that, and it's going to be a bit slow here.
let me
The way
just
it works,
close
no,
this
not
here.
that.
I'd said that there's this pothole detection problem we are working on, right? I don't know if you remember, it was at the beginning, but maybe you understand this a lot easier. And we said we built this in such a way that it kind of tells us, right, which portions of roads here have potholes and stuff. Now, the idea is the same, right? But the features we're using here are images. And it turns out that when we're looking at images, the features are not really the images themselves, but what is that now? Are not the images themselves, but the pixel representations of the images, right? So it's like RGB and alpha or something. That's it. You know, so really, this thing is not, when you're mining data and you're trying to build inference models, really the idea is the same. All right. Again, it doesn't matter whether you are like Malaysia and you're working with medical images, the idea is the same again. So I'm going to pause here and ask if there are questions. The next time we meet, I think we're supposed to have a makeup class or something. We can probably meet on Sunday or something. I will reach out to you. I'll check my records. The next time we meet, we're supposed to start our discussion of lecture series number 4, where in lecture series number 4, actually, what we're doing in this lecture series is we're looking at the approach, right? The activities that you perform in a typical data mining pipeline. What we're now going to do is we're going to go back, but not way back. We're going to start with data preparation, right? So that we see how we pre-process information, how we transform data, right? And then we'll move on to modeling and stuff. Are there any questions about this? I think this is pretty easy, really, in my opinion. Colleagues, if there are no questions, I'll let you go. Thank you very much. And is that a question?
Mr. Piri?
Yes.
Yes, I wanted to find out. I think I missed you said we should read a paper, but then I'm not quite sure which directory it is. So are you going to share them?
Yeah, I mean, I can add it on the Google Classroom site, but I've just pasted it in the in-com messages. It's this paper here. Usually when I'm interacting with students like this, it's an opportunity to make them read what we do, what we have done. So it's this paper called Controlled Vocabularies in Digital Libraries, Challenges and Solutions for Increased Discoverability of Digital Objects. This thing, by the way, we are proud here. We published this in the, we presented work at the JCDL conference. They invited us to extend this, and then we submitted it to Digital Libraries Journal, really. This is work based on a capstone project. So Bertha, Eric, Andrew, Phenomenon, and Daisy worked on this capstone, on their capstone. There's aspects of their capstone. And then Robert worked on his masters. There's aspects of his masters, yeah. So, you know, Dr. Nyirenda and myself, so Mambo Nyirenda and myself, supervised Robert. You know, so this is the paper here. I will also put it up on Google Classroom if that will help. It's to help you understand. It's to help you understand this last case study. I said the last case study you can, but where is it now? You can go and read up yourselves, right? This case study number 4. It's a paper here. Okay, we're building multi-level classifier. With that being said, colleagues, thank you very much. You know, UNZA is not just about, you know, classes and, by the way, my student is presenting next week, Wednesday. Please join in. He's going to be talking about medical images. Yeah. He's defending his thesis. He was doing a master's by research. There's open day. Apparently there are no classes on Friday. Take time off work and go and unwind, right? And mingle with people. Who knows? I don't know, maybe you find a potential collaborator for your part 2 or something like that. You should take these things serious. Thank you very much, everybody, and enjoy the rest of your Wednesday or something like that. Bye.